Greetings everyone, welcome to another episode of the organic chemistry course. Now, in today's episode, we're covering carbonyl compounds. So the first subheading there, we're dealing with the formation of aldehydes. So carbonyl compounds involve aldehydes and ketones. So let's see how we form aldehydes. First of all, aldehydes are formed when primary alcohols are oxidized by a weak oxidizing agent such as potassium dichromate 6, right? There is a color change from orange to green when this happens, when this oxidation happens. So you have your alcohol here being oxidized or warmed. You're using an oxidizing agent such as potassium dichromate 6 to produce your aldehyde. We covered this in the previous video, okay? It's just a reinforcing of what you've already done. So during oxidation, a mixture of the aldehyde and the carboxylic acids are formed. So to get the aldehyde, you must distill. This is just a nice to know statement there. There's nothing new that I've said so far that you did not hear in the previous video. Okay. Now let's talk about the formation of ketones. Ketones are formed from the oxidation of secondary alcohols. We say this right. They are oxidized by acidified potassium manganate 6 or potassium dichromate 6. And during this reaction, secondary alcohols are converted into ketones. That's all. So here I just wrote there to say the oxidizing agent can either be potassium dichromate 6 or it can be what? Potassium manganate to give you your what? Your ketone over here. So say you use acidified potassium manganate. There is a color change from purple, right, to colorless. Now let us talk about reduction of aldehydes. Remember, to produce the aldehyde, we had oxidized in alcohol. So if you are now reducing it, you're reversing the oxidation reaction back to the what? To the alcohol. So aldehydes are reduced to primary alcohols by reducing agents such as sodium borohydride in methanol, right? Lithium aluminium hydride in dry ether, hydrogen over a nickel catalyst at 150 degrees Celsius and 4 atm. So I've put all the reaction conditions here. Either of the three works. So you've got your aldehyde here, right? Being reduced, being reduced. You show that a reduction reaction is happening by adding hydrogen, right? Most of the time to produce your primary alcohol over there. Reduction to ketones. Ketones are reduced to secondary alcohols by the following: sodium borohydride in methanol, lithium aluminium hydride in dry ether, hydrogen over a nickel catalyst at 150 degrees Celsius and 4 atmospheres. Right? So you've got your ketone over here being reduced by either one of the following, either one of these, to produce your what? The secondary alcohol. That's all. Now the mechanism for the nucleophilic addition of carbonyl compounds. This is something that we say is now new that you've not covered in the previous topic. Okay, so the nucleophilic addition of HCN to carbonyl compounds, usually we're adding HCN, right? So let's get down to it and show you how the chemistry happens. So HCN is a weak acid. So the concentration of cyanide ions is very small. As a result, the rate of the reaction will be very slow. So what do? We try to increase the concentration of cyanide ions by adding traces of KCN or sodium cyanide, right? These are salts that dissociate to give a higher concentration of cyanide ions, thus increase this concentration. Okay? There's another alternative method as well, which is the most common as far as your exams are concerned, whereby you add a base to your cyanide, producing your H2O and your nucleophile, right? This increases the concentration of hydrogen ions. So as far as the mechanism is concerned, we said this is the first step that we just did, right? You produce your cyanide ions, right? And now this nucleophile has a lone pair of electrons on it, which attacks these ones. They're the ones, let me use a red marker, yes, red ones here. These lone pair of electrons are the ones that are attracted to the positively charged what? Partially positive oxygen atom, carbon atom. Because the oxygen here is very electronegative, it withdraws electrons from the bond, making carbon slightly positive and itself negative, right? What then happens? This bond becomes this one of the electrons of the bond are taken by the oxygen, right? In such a way that the double bond breaks to create a single bond, but the oxygen here becomes negatively charged, right? It's called an anionic intermediate. Then you put back the water, right? The water then comes back now. Water is a polar molecule. The oxygen atom polarizes the oxygen atom becomes partially negative in the hydrogen here positive, right? It is then the one that it is then attacked by the negatively charged ionic intermediate here to produce a cyanohydrin, right? Plus a regenerated OH catalyst, which is a catalyst, right? So that's all there is to it. So if this the carbonyl compound I used there was a ketone, if it was an aldehyde, it doesn't matter. Maybe this bond here, for example, this bond here, for example, would be hydrogen. The mechanism will still be the same. It's a mechanism not for ketones only, but for aldehydes as well, representing their family of what of carbonyl compounds. And what they wanted you to know is that this reaction is a nucleophilic addition reaction. So the next page is more clear. It's the same page of the same what page. Now I want to talk about carbonyl compounds. Carbonyl compounds are tested using 2,4-dinitrophenylhydrazine, or in short 2.4 DNPH, right? When a carbonyl compound is mixed with 2.4 DPNH and a little sulfuric acid added, the mixture is heated, right? A yellow or orange precipitate is formed. A yellow or orange precipitate is formed. So below here is just an example of how the aldehyde. Here's your aldehyde reacting with what? 2,4 DNPH, right? What then happens? The oxygen atom here, the oxygen atom here is broken, right? The oxygen atom here is broken. And one of the hydrogen atoms here or let me say, how can I put it? How can I put it? Two of these hydrogen atoms are also removed to form this H2O that is over here. And the new structure is created like this. I hope you see it. So here, instead of having two hydrogen atoms, we have a double bond with the what? Where the oxygen was. And you form your what? Your 2.4 dinitro, your double bond. You form your phenylhydrazones. These are said to be compounds with a characteristic melting point. So both aldehyde and ketones give an orange precipitate with 2,4-DNPH. Okay. Now testing for aldehydes. I promise to give these in more detail. Okay. Testing for aldehydes. We can test aldehydes using Fehling solution or Tollens reagent. Using Fehling solution is an alkaline solution of copper 2 plus ions. It is blue in color. If Fehling solution is added to an aldehyde and heated, a brick red precipitate of Cu of copper 1 plus ions is formed. Oh my goodness. Let me see. The next one is Tollens reagent. Tollens reagent is an ammonical solution of silver nitrate. Tollens reagent reacts with aldehydes to form a silver mirror precipitate or a gray precipitate. So this is the equation that shows how they react. Okay, so the precipitate here is coming from the silver here. This is the equation showing how it happens, right? Now, I want to move on. This is how we test, guys. I think I've explained what these reactions in the previous video, but I've been more clearer in this video on this one, right? The triiodomethane test. We did this triiodomethane test in the previous video as well, when we were talking about methyl alcohols. When we spoke about methyl alcohols, right? Right, methyl alcohols. But it also is also useful for methyl ketones, right? A ketone is a carbonyl with two other groups, right? But a methyl ketone, one of the other groups is a CH3 bond. So ethanol, here's a point, here's a takeaway from this. Ethanol is the only aldehyde when the other here is a hydrogen, right? Methanol is the only aldehyde that shows a positive triiodomethane test. Ethanol is the also shows a positive triiodomethane test. But ethanol is just an alcohol, right? It's a methyl alcohol. Ethanol. It's a methyl alcohol, right? Now, down here, I was saying, if a compound shows a positive triiodomethane test, we will see a yellow precipitate. So for an aldehyde, this is just an equation that I wrote here that indicates what happens, right? You add 3I2 plus 4OH negative, you produce your triiodomethane test, which is this one, triiodomethane, right? Plus your iodide ions, your carboxylate ion, and 3H2O. In this example now, in this example, I used this aldehyde as a typical example. The R here was replaced with an, let's call this a propyl group, right? To produce this equation that you have over here. Okay, that's all there is to it. So why are these equations important? In your paper 2 or your multiple choice, they are going to ask you this equation, and they shall require you to know the coefficients of every species that you have in this equation. So this equation will be very, very important. Okay, so I hope you found this video helpful, and if you did, please help support the channel by commenting, liking, sharing, and subscribing. And I'll see you all next time. Thank you and take care.